Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem solve d square minus 3d plus 2 into y equals to 2x cube minus 9x square plus 6x. So firstly, let's find the order and degree of the given differential equation. Identify the highest derivative in our problem. Here d square is the highest derivative, so our order will be 2. And the highest power of the highest derivative is a degree. Degree is 1. Or just write the given differential equation as d square y minus 3dy plus 2y equals to 2x cube minus 9x square plus 6x. We know that d is a differential operator, so we can write d as d by dx and d square as d square by dx square. So the equation becomes d square y by dx square minus 3 into dy by dx plus 2y equals to 2x cube minus 9x square plus 6x, right? Here d square y by dx square is the highest derivative, so our order is 2, and the highest power of the highest derivative is a degree. Degree is 1. Now coming to the problem. Given differential equation, d square minus 3d plus 2 into y equals to 2x cube minus 9x square plus 6x, which is in operator form. F of d into y equals to q, where f of d equals to d square minus 3d plus 2 and q equals to 2x cube minus 9x square plus 6x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function. We'll find this using the roots of auxiliary equation of the homogeneous equation of the given non-homogeneous equation, right? So by putting RHS to 0, we'll get f of d into y equals to 0, which is a homogeneous equation of the given non-homogeneous equation. And we'll find yp using 1 by f of d into q. Okay, here q is an x power k form, right? So here x cube is the bigger one, right? I mean x power 3. Here 3 is the highest power we have from all these 3. So for k equals to 3, we'll get derivative still d cube. Okay, we'll get d or d of q, d square of q and d cube of q. And from d power 4, d power 5, d power 6 will get 0. What I mean is d power k of q is 0 for k equals to 4, 5 and so on. Okay, we'll see while finding yp. Now let's find yc firstly. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square minus 3d plus 2. Now let's replace d by m, so that we'll get f of m equals to m square minus 3m plus 2. Then our auxiliary equation becomes m square minus 3m plus 2 equals to 0. Now split this minus 3m as minus 2m minus m, right? Plus 2 equals to 0. Now let's take m common from the first two terms. We'll get m times m minus 2, and take minus common from the next two terms, then we'll get minus of m minus 2 equals to 0. See, minus into m minus m, minus into minus plus 2. So if you notice, we are having m minus 2 in both the terms. So let's take m minus 2 common. We'll get m minus 2 into m minus 1 equals to 0. Now equate each factor to 0. M minus 2 equals to 0 and m minus 1 equals to 0. From m minus 2 equals to 0, we'll get m equals to 2. From m minus 1 equals to 0, we'll get m equals to 1. So from this, we'll get m equals to 2 and 1, which are the roots of our auxiliary equation. Therefore, m equals to 2, 1 or m equals to 1, 2 are the roots of our auxiliary equation f of m equals to 0, which are real and distinct or real and different. We know that when two roots say m1, m2 are real and distinct, if two roots say m1, m2 are real and distinct, then yc will be c1 e power 1 root into x plus c2, another constant into e power another root into x. Now let's write complementary function using this formula. Yc equals to c1 e power 1 root into x plus c2 into e power another root into x. Then yc equals to c1 e power 1 into x is x plus c2 into e power 2 into x, 2x, which is our required complementary function. Now let's find particular integral. We'll find particular integral using yp equals to 1 by f of d into q, which is equals to 1 by f of d. We have d square minus 3d plus 2 and q is 2x cube minus 9x square plus 6x. Firstly, let's find derivatives of q. Derivative of q, 2x cube minus 9x square plus 6x is derivative of x cube with respect to x is 3x square minus 9 into derivative of x square with respect to x is 2x plus derivative of x with respect to x is 1, right? We get 2 3s are 6x square minus 9 2s are 18x plus 6. Derivative of q, two x cube minus 9x square plus 6x is 6x square minus 18x plus 6. Now let's find d square of q. Which is equals to derivative of q. We have the value of derivative of q. 6x square minus 18x plus 6. Now let's find its derivative. We'll get 6 into derivative of x square 2x minus 18 into derivative of x is 1 plus derivative of constant is 0, which is 6 2s are 12x minus 18. Derivative of q is 12x minus 18. Now let's find d cube of q. This is equals to derivative of d square of q. Use the value obtained from d square of q, 12x minus 18. Derivative of 12x is 12 minus derivative of constant is 0. So d cube of q is 12. Now find d power 4 of q. This is equals to derivative of d cube of q. We have the value of d cube of q, which is 12. And we know that derivative of constant is 0. So d power 4 of q is 0. So from here we'll get higher derivative 0, 0, 0, 0. Right? That is d power 5 of q is 0. D power 6 of q is 0. And so on. Which is nothing but in general d power k of q equals 0. For k equals to 4, 5, 6 and so on. Right? Here x cube is the highest power. Here 3 is the highest power, I can say, from all this 1, 2, 3. From 1, 2, 3 we have 3 is the highest power. So we'll get derivatives till d cube, and from 4, 5, 6 we'll get zeros. Right? D power k of x power k is q is 0 for k equals to 4, 5, 6 and so on. Now coming to yp again. Here our f of d is in decreasing order. Let's take this 2 common from all the terms. Then we'll get 1 by. See, in the first 2 terms we don't have any 2, right? So let's multiply and divide 2 to these 2 terms. Then we can write f of d as 2 by 2 into d square minus 3d plus 2 into q, which is equals to 1 by. Now take 2 common from the 2 terms. We'll get 2 times 1 by 2 into d square minus 3d plus 1. See, 2 into 1 by 2 into d square minus 3d is 2 by 2 into d square minus 3d plus 2 into 1 is 2. Okay? Nothing has changed. Now, let's write this fraction as 1 by 2 into 1 by 2 into d square minus 3d is d square minus 3d by 2 plus 1 into q, 2x cube minus 9x square plus 6x, which is equals to 1 by 2 into, I can write these 2 terms as some 1 plus this term d square minus 3d by 2, right? Nothing has changed. Now, let's split the fraction into 2 fractions. 1 by 2 into 1 by 1 plus d square minus 3d by 2 into q, 2x cube minus 9x square plus 6x. See, the second fraction is of 1 by 1 plus x form, so we can write it as 1 plus x whole inverse. Or for our convenience, we'll take minus common from these 2 terms. Okay, for our convenience. See what happens. Then I'll get something like this, which is in 1 by 1 minus x form. Then we can write it as 1 minus x whole inverse form, right? Either you can expand 1 plus x whole inverse, or you can write the denominator in 1 minus x form, and you can use 1 minus x whole inverse binomial series expansion. Okay. While Using 1 minus x whole inverse, we'll get alternate signs. There's a chance of getting confusion. So instead of using 1 plus x, you can also use 1 minus x whole inverse form, because here we are having a possibility to use 1 minus x whole inverse also. Here you don't need to change any signs, we'll have only plus. Okay. So I'll pick the second one and we'll show you how to find yp using this. Okay. Now we'll write the second fraction as 1 plus, I'll write d square minus 3d as minus 3d plus d square by 2 into 2x cube minus 9x square plus 6x. In the beginning itself, you can change f of d like this. Okay. You can just write the terms in ascending order. Let me show you once. We are having f of d equals to d square minus 3d plus 2, right? So let's write it in ascending order. Now let's take 2 common from all the terms. We don't have 2 in the next 2 terms, right? So let's multiply and divide the 2 to the next 2 terms. Now we'll take 2 common, then we'll get 1 plus 1 by 2 into minus 3d plus d square, right? Now take minus common from these 2 terms, then here you'll get minus 1 into plus minus. It is easy, right? So you can write this as 2 into 1 plus into minus minus 3d minus d square by 2, right? F of d becomes 2 into 1 minus 3d minus d square by 2. That is what I am going to change here. Okay. At the beginning itself, you can change it. Or if you missed the step, or if you didn't notice any minus in between, you can change it later. There's nothing wrong in it. Plus, now take minus common, we'll get minus of 3d minus d square by 2 into q, which is equals to 1 by 2 into 1 by 1 plus into minus minus 3d minus d square by 2 into q, 2x cube minus 9x square plus 6x, right? See, we have changed f of x in 1 minus 3d minus d square by 2, 1 minus x form, I can say. Now yp becomes 1 by 2 into 1 by 1 minus x. We know that 1 by 1 minus x can be written as 1 minus x whole inverse. So we'll write this fraction as 1 minus 3d minus d square by 2 whole inverse. Now we can use binomial expansion series to expand 1 minus x whole inverse. We know that 1 minus whole inverse is 1 plus x square plus x cube plus so on, right? And we know that the derivatives from d cube is 0, so we'll neglect higher powers from d power 4, d power 5, or highest derivatives from d power 4. Okay. And now let's see the expansion of 1 minus 3d minus d square by 2 whole inverse, which is equals to 1 plus 3d minus d square by 2 plus 3d minus d square by 2 whole square plus 3d minus d square by 2 whole cube. Okay. From x power 4, from here from the next term, we'll get higher powers or higher derivatives, I can say. Okay, now let's expand these. Firstly, let's expand 3d minus d square whole cube using a minus b whole cube formula, which is a cube minus b cube minus 3ab into a minus b. Okay, this is equals to 3d whole cube minus d square whole cube minus 3 into d square. Okay, 3 into a, 3 into 3d into d square into 3d minus d square, which is equals to 3 3 is a 9, 9 3 is a 27 d cube minus a square whole square. A power m whole power n is a power m into n, so you'll get d power 2 3 is a 6 minus 3 3 is a 9 into d square is d cube into 3d minus d square, right? 9d into 3d, 9 3 is a 27 into, this becomes, I'll write it here, 3d minus d square whole cube is 27d cube minus d square, sorry, d power 6 minus 9 3 is a 27, d cube into d is 3 plus 1, 4, minus into minus plus 9, d cube into d square, 3 plus 2, 5. So you are getting higher derivatives, d power 6, d power 4, d power 5, which has to be eliminated or neglected. Okay, just neglect these three terms. Now coming to the binomial expansion, you'll get 1 plus, you can write this as 1 by 2 into 3d minus d square plus 3d minus d square whole square by 2 square, which is 4, plus 3d minus d square whole cube by 2 cube. 2 cube is 8, right? Now the expansion becomes 1 plus 1 by 2 into 3d minus d square plus 1 by 4 into expand 3d minus d square whole square using a minus b whole square formula. Okay, is equals to 3d whole square, 3 square is 9 into d square plus d square whole square is d power 2 2 is a 4 minus 2 3 is a 6, d into d square is d cube. Then you'll get 1 by 4 into 3d minus d square whole square. Expansion is 9d square plus d power 4 minus 6d cube. Okay, plus 1 by 8 into expansion of 3d minus d square whole cube. Plus 1 by 8 into expansion of 3d minus 2d square whole cube is 27d cube minus d power 6 minus 27d power 4 plus 9d power 5. Right? So now identify the highest derivatives. Okay? Keeping in mind that only we have values of q for d, d square and d cube. So we can neglect d power 4 from third term and d power 6, d power 4, d power 5 from the last term. Right? Fine. Now coming to yp, we'll expand this 1 by 2 into 1 plus x 3d minus d square by 2 plus 3d minus d square by 2 whole square plus 3d minus d square by 2 whole cube plus so on, right? Expansion of 1 minus x whole inverse is 1 plus x square plus x cube plus so on into cube. 2x cube minus 9x square plus 6x, right? Since, okay, firstly let's write, okay. Since d power k of q is 0 for k equals to 4, 5, 6 and so on, so neglect higher derivatives from d power 4, d power 5 and so on, right? Now our yp becomes, we are going to neglect terms from power 4, power 5, power 6 and so on from here, right? Then yp becomes 1 by 2 into 1 plus 3d minus d square by 2 plus 3d minus d square by 2 whole square plus 3d minus d square by 2 whole cube into cube. 2x cube minus 9x square plus 6x. This becomes 1 by 2 into 1 plus 1 by 2 into 3d minus d square plus, you can write 3d minus d square whole by 2 whole square as 3d minus d square whole square by 2 square plus 3d minus d square whole cube by 2 cube into cube. 2x cube minus 9x square plus 6x, right, is equals to 1 by 2 into 1 plus 1 by 2 into 3d minus d square plus 1 by 2 square 4 into expansion of 3d minus d square whole square is 9d square minus d power 4 minus 6d cube plus 1 by 2 cube. 2 cube is 8 into expansion of 3d minus d square whole cube is 27d cube minus d power 6 minus 27d power 4 plus 9d power 5 into cube. 2x cube minus 9x square plus 6x. Now I'm going to neglect higher derivatives, d power 4, d power 5 and d power 6, right? Now this becomes 1 by 2 into 1 plus 1 by 2 into 3d minus d square plus 1 by 4 into 9d square minus 6d cube plus 1 by 8 into 27d cube into cube. 2x cube minus 9x square plus 6x, right? This is equals to 1 by 2 into 1 plus 1 by 2 into 3d is 3 by 2 d plus into minus minus 1 by 2 into d square is 1 by 2 d square plus 1 by 2 into 9d square is 9 by 4 d square plus into minus minus 1 by 4 into 6 is 6 by 4 into d cube plus 1 by 8 into 27 is 27 by 8 d cube into cube. 2x cube minus 9x square plus 6x. Then yp becomes 1 by 2 into 1 plus, only we have one d term. The term involving d is only one. 3 by 2 into d. Now write the terms involving d square. You can just write this 2 as 9 by 4 minus 1 by 2 into d square. Now take the terms of d cube plus 27 by 8 minus 6 by 4 into d cube into cube 2x cube minus 9x square plus 6x. Let's find 9 by 4. Simplify. 9 by 4 minus 1 by 2. LCM of 2 and 4 is 4. The numerator will get 9 minus the denominator of second term you are having 2 close to. So multiply this 2 to 1. You'll get 1 into 2, 2, which is equals to 9 minus 2, 7 by 4. So 9 by 4 minus 1 by 2 is 7 by 4. And now let's find this. 2 3s are 6, 2 2s are 4, right? So 27 by 8 minus 3 by 2 is, find LCM of 8 and 2. 2 1s are, 2 4s are 8, 2 2s are 4, 2 2s are 4, 4 2s are 8. 8 is LCM. The numerator will get 27 minus, in the denominator of second term you are having 2, so close 1 2. 2 2s are 4. Multiply 4 to this 3, you'll get 3 4s are 12. 27 minus 12 is 15 by 8. Now our YB becomes 1 by 2 into 1 plus 3 by 2d plus 7 by 4d square plus 15 by 8d cube into cube 2x cube minus 9x square plus 6x is equals to 1 by 2 into 1 into q is q plus 3 by 2 into d of q plus 7 by 4 into d square of q plus 15 by 8 into d cube of q. Now YP becomes 1 by 2 into 2x cube minus 9x square plus 6x plus 3 by 2 into derivative of q is 6x square minus 18x plus 6 plus 7 by 4 into d square of q is 12x minus 18 plus 15 by 8 into d cube of q 12 is equals to 1 by 2 into 2x cube minus 9x square plus 6x plus 3 by 2 into 6x square minus 3 by 2 into 18x plus 3 by 2 into 6 plus 7 by 4 into 12x plus into minus minus 7 by 4 into 18 plus 15 by 8 into 12. 2 1s are, 2 3s are 6, 2 1s are, 2 9s are 18, 2 1s are, 2 3s are 6, 2 2s are 4, 2 6 are 12, right? 2 1s are, 2 3s are, 4 3s are 12, 2 2s are, 2 9s are 18, 2 4s are 8, 2 6s are 12, 2 2s are 4, 2 3s are 6. Our YP becomes 1 by 2 into 2x cube minus 9x square plus 6x plus 3 3s are 9 x square minus 3 9s are 27x plus 3 3s are 9 plus 7 3s are 27 x, sorry, 7 3s are 21x minus 7 9s are 63 plus 15 3s 45. Okay, in the denominator you'll get 7 9s are 63 by 2 plus 15 3s 45 by 2 minus x square, sorry, minus 9x square plus 9x square gets cancelled and you'll get 1 by 2 into 2x cube plus 6x plus 21x is 27x minus 27x, right, and plus 9 minus 63 by 2 plus 45 by 2. See, from 15 by 8 into 12, we got 45 by 2, right? Fine. Now let's simplify. Simplify 9 minus 63 by 2 plus 45 by 2. Here LCM is 2. 2 9s are 18 minus 63 plus 45. 45 plus 18 is 63. Right? So you'll get 63 minus 63 by 2, which is equals to 0 by 2. 0, right? This term becomes 0. Then our YP becomes 1 by 2 into 2x cube plus 27x. See here, plus 27x minus 27x gets cancelled. So you'll get 1 by 2 into x cube plus 0, right? Which is equals to 1 by 2 into 2x cube. Again, 2 gets cancelled. Finally, you'll get YP equals to x cube. Now let's write the general solution. The general solution is given by y equals to yc plus yp. Then our solution will be y equals to yc, c1 e power x plus c2 e power 2x plus yp x cube. This completes the problem. We have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.